I have some self-service thing. All right, let's see. That's me, and this is my presentation. I'm very happy to be here in Stockholm, presenting what is actually Denmark's first commercial satellite operator, and also the world's first commercial satellite operator targeting the new AIS 2.0 technology, building a satellite constellation on that technology. So the starting point is that the maritime industry is kind of conservative, but a lot of digitalization is happening. So there are more and more systems on the ship bridge which are digital, electronic charting system, and so on. The problem, so you really want to get access to things like navigational warnings from maritime authorities. You get them through different sources today. You want to be able to coordinate digitally with ports, with other ships, and there's a lot of talk about autonomous shipping. But the big problem today is that internet is banned on the ship bridge, so you cannot connect the systems on the ship bridge to achieve these things. The solution is that some smart people, like myself, have come up with AIS 2.0, building on top of the old AIS system, now formally with a new name, DHF Data Exchange System, short DHS. So it's an extension of AIS, which is this global tracking system that used for monitoring ships. But then it's also a new open data channel, an IP-free open data channel. And why is it IP-free? That's because you can make a data connection then without any risk at all for opening the door for a hacker who would use an IP connection to penetrate the systems on the ship bridge. So that it's like an unbreakable firewall, a firewall without exceptions, except for the possibility of sharing trusted data like navigational warning and more optimal route if you have a route optimization system, and so on. And it has recently become a global standard, so with its own radio spectrum in the VHF bands, which does give you the high data rates, as I think James was talking about. On the other hand, VHF frequencies are extremely robust towards weather, towards all kinds of things. So it's a very reliable and stable data connection that you can get anywhere in the world from satellite, and the antenna on board the ship is still the good old VHF antenna that you use today. Two-way data from satellite to the satellite from the ship. And it's an ICU standard. It's expected to become written into the SOLAS Convention here in May. Hard work is done by IALA. Other technologies or parts of it has been built through these organizations that we are very active in Sternula. So talking about collaboration, it's also something that fits into a maritime domain awareness system, because you know AIS is kind of a starting point when you want to monitor ships. You start out looking at the AIS data that gives you a picture of what ships voluntarily provide. And then you have the sensing systems, you have imagery, you have a SAR system, you have IF emissions monitoring, and then in between you have AIS 2.0 as something that adds trust to AIS, because the big problem in AIS is also it's quite easy to make fake data. Spoofing is a problem. Anyone can send out, pretend to be this masked vessel, and you have no way of checking it. With the extra open data channels in AIS 2.0, you can actually make a handshake with a digital signature, so you know that the one who claimed to be the masked vessel is in fact a masked vessel. So it's a global standard. It's also a system which is a combined satellite system and coast network system. So also the coast stations are being upgraded. The first country in the world to make full transfer of the old AIS coast stations to VDES is Sweden. So right as we speak, Sweden is changing all the coast stations from AIS to AIS 2, and that's also of course a big milestone for technology to go into the market. So what we do in Sternula is we launch satellites. We have launched one satellite, want to build a satellite constellation of up to 6 satellites. So we sell satellite capacity to add to the coast. So starting from the maritime authorities, which is the first time customer, will be building their coast stations, and then they will need to extend that capacity into the big oceans. So that's where satellites come in. So this is what we provide. We also provide the back-end side. So Sternula is in fact more. We have a background in telecommunications. So where the official standard VDES is a radio interface, it doesn't really have a core network part and a networking part. So we also provide that to those operating both satellite networks and coastal networks. We launched the company in 2019. We launched our first satellite in 2023. So we've been using that as a starting point for pilot projects. So we now have pilot projects all over the world. From these pilot projects, we now just passed the milestone of 1 million euros of revenues. And yeah, this is from the 3rd of January 2023 when we launched our satellite. On a Falcon 9, here it came out. The people working hard, and the people taking all the credit and drinking champagne. So this is the roadmap. We want to launch another 4 satellites in 2026, maybe 2027. For that, we're currently seeking investors. Then we're focusing on broadcasting services, occasional warnings. Then we need another 16 satellites by 2028 to enable more two-way services where we can do different handshakes, request for a digital signature, get a response, and then we want to have the full constellation operational from 2030, where it's also estimated by the analysts to be the sort of the peak of this market, which is estimated to more than 3 billion euros. Thank you.
Wonderful.